Hello, this is David Adams, and today I'm going to be presenting my research project titled I'm All Ears. So let's begin. So, first, let's begin by looking at my research question. So, for my research question, I did how does the human ear hear sound, right? Well, I chose this question because I have a really strong passion for making music, and in the process of making music, you have to be very attentive to the different pitches and tones and making them go together while making music. Which just made me curious, how does the human ear work or how does it perceive sound exactly? So before we get into the details of answering my question, it's very important to understand exactly what sound is. So, what is sound, right? Well, sound is a sequence of pressure changes over time, and it comes from vibrations that form a sound wave. For example, when you're playing a guitar and you strum the strings, right? Well, they then vibrate very fast, and the vibrations then travel into the guitar, which then are amplified inside and exit the guitar, creating a nice loud sound. And all sounds produce sound waves, and depending on the strength of the frequency, is how it is perceived to the listener. So, for example, the faster the waves are, the higher the sound will be. And the slower the waves are, the slower the sound will be. So, a sound wave, it's made up of three basic parts. You have frequency, amplitude, and temporal variation. So, first, we're going to talk about frequency. And frequency is simply just the number of times a point on a wave passes a fixed reference point in about 1 second. Next, we have amplitude, and amplitude just refers to the sound pressure or the length and width of a wave. And then temporal fluctuations is simply the amount of time that the sound is played for. And then next, we have the ear. So I'm basically going to go over the basic layout of the ear. So it's cut up into about four different sections. You have the outer ear, the middle ear, the inner ear, and then your central auditory nervous system. So first in the outer ear, you have the pinna up top, that fleshy part of the top of your ear. And then you have the concha down below, which basically forms your external ear canal, which then down the ear canal, you would hit your eardrum. And then after the eardrum, you have the malleus, the incus, and then leads to the stapes. And then from the stapes, you have the cochlea, which the cochlea looks like a little snail shell almost. And then after the cochlea, it would travel then into the central auditory nervous system, where it would be processed and the listener would then hear the sound. So now that we've got the basic layout of the ear down, let's talk about how exactly it works when sound enters the ear. So the first part of the ear that helps capture sound is the pinna, and then the external ear canals help with the process of sound entering the ear. So sound is then brought into the eardrum after it enters the ear canal, the external, which is made up, and the eardrum is made up of minute ear bones known as ocelles, which then would direct vibrations into the inner ear, where they would enter the cochlea, that small snail shell looking thing. So the malleus and the incus and stapes would then help with the transfer of sound after the eardrum into the inner ear, where there is a buildup of tissue and fluids. So when vibrations enter in through the external ear canal, which then hit the eardrum, the vibrations are then transmitted into the stapes foot plate, and then the foot plate would then move it into the oval window of the inner ear, which would set the fluids in the inner ear in motion to be processed. Then the vibrations, when they hit the fluids and hair cells, they would then be converted into nerve impulses and reach the brainstem where it'd be processed so that way you can hear sound. So that's basically how it works and how you hear sound. Now I'm going to talk a little bit about really the importance of sound So, sound is one of the key elements to how our world works. And I think a lot of us really take for granted the ability that God's given us to hear. And we react to certain situations because of the sounds we can hear. For example, when you're driving on the road and you hear a high pitched siren from an ambulance, your brain automatically knows that you need to get out of the way, right? When someone calls for help, you know that someone may be in danger or that you need to help someone, right? So sound is really involved in our everyday lives, and it's involved in everything we do and everything we learn, teaching, and how we communicate every day. And that's basically my research project. And these are my works cited, and that's it. Thank you for listening.